Dear learner, I welcome you all in this MOOC course on Principles of Electrical Sciences. I am Dr. Sanjay Agrawal, Electrical Engineering Department, School of Engineering and Technology, IGNOU. In this session, we are going to discuss about the DC circuit. In this DC circuit, we will discuss about what is the active circuit, what is a passive circuit, what is a unilateral circuit, bilateral circuit. Then we will discuss about the different type of energy sources, that is ideal voltage source, ideal current source, then how to convert current source into voltage source and voltage source into current source. Then we will discuss about two very important law, that is KVL, that is Kirchhoff's voltage law, and KCL, that is Kirchhoff's current law. So let us start DC circuit. So first of all, we have to discuss what is the electric circuit. An electric circuit is a closed conducting path through which an electric current either flows or is intended to flow. Then we have to understand what is electric network. A combination of various electric elements connected in any manner is called an electric network. So electrical circuit is a combination of different circuit elements, and these elements may be the resistance, inductance, capacitance, and maybe energy sources. But difference between circuit and network, circuit will always be closed, network may be open or may be closed. So here you can see in the diagram that in the first diagram you can see there is a circuit which have three basic electrical elements, that is resistance, inductance and capacitance, and all these three elements are connected in series with 120 volt voltage source. So this is a one circuit. And another example that you can see, that is a delta network. This is also a network in which there is three resistance are denoted as RAC, RBC and RAB. In the star connection again there is three resistances, that is RA, RB and RC. So you can observe here that this particular star connection is open. So this open connection is basically a network. So circuit will always be closed and network may be open or may be closed. So this is the difference between circuit and network. Now we have to understand what is a short circuit. Generally it is said that short circuit happens. A short circuit happens when a path of zero resistance is connected between two terminals. The resistor shown here in the figure is the actual path for the current, and the curved wire going around it is the short circuit path. It is to noted that current always flows through the least resistance path. So here you can see there is a one resistance is connected, and across the resistance there is a one wire is connected which have zero resistance. So whenever voltage will be applied across this resistance, so current will always flow through only the least resistance path. So it will behave like a short circuit, because current flowing through this circuit is equal to I equal to B upon R. In this case, equivalent resistance is zero. So current is what? That is infinite current will flow through this circuit. Now we have to understand the different circuit element or the parameter. The various elements of an electric circuit are called its parameter, such as resistors, inductors and capacitors. The term circuit element means component and sources. Here you can see the different symbols of the different electrical element like resistance, capacitor, inductor, battery and voltage source and current source. Now we have to understand what is active element, as name is indicative active. So active element are the element of a circuit which possess energies of their own and can impart it to or other element of a circuit. Active element are of two types. It may be the voltage source or it may be the current source. Voltage source has a specified voltage across its terminal independent of current flowing through it, and current source has a specified current through it independent of the voltage appearing across it. In diagram you can see there is a one battery and there is another bulb. So this battery is working as an active element and the bulb will work as a passive element, because this battery is giving energy to the bulb. So that means this bulb is receiving some energy from that active element, that is battery. So battery is an active element and this bulb is a passive element. Now we have to understand what is passive element. The passive element of an electric circuit do not possess energy of their own. They receive energy from the sources. So example of passive element are resistance, inductance and capacitance. Here you can see in the diagram there are different components has been shown in the diagram like resistor, inductor and capacitor. When electrical energy is supplied to a circuit element, it will respond in one or more of the following ways. If the energy is consumed, then circuit element is a pure resistor. If energy is stored in a magnetic field, the element is a pure inductor. And if the energy is stored in an electric field, the element is a pure capacitor. Now we have to understand the difference between linear circuit and non-linear circuit. So first of all, we will discuss what is a linear circuit. An electric circuit that contains parameter of constant value, that is, their value do not change with the voltage or current, is called linear circuit. So what is a non-linear circuit? An electric circuit that contains parameter whose value changes with voltage or current is called non-linear circuit. Now we have to say what are the example of the linear circuit and non-linear circuit. The current passing through a resistor is proportional to the voltage applied through it, and the relation is expressed as VI, or it can also be written as V equal to IR. A linear element or network is one which satisfies the principle of superposition, that is principle of homogeneity and additivity. Resistors, inductor and capacitor are the examples of the linear element, and their properties do not change with the change in the applied voltage and the circuit element. It can be seen in the following diagram, which have two basic elements, resistor and inductor, and these two elements are connected in series with the voltage source. So here you can see the linear relation between voltage and current. Non-linear elements VI characteristic do not follow the linear pattern, that is, current passing through it does not change linearly with a linear change in the voltage across it. Example are the semiconductor device such as diode and transistor. Here you can see one diode is connected between the load and the AC supply, and you can see the characteristic here you can see the IV characteristic, and you can see there is no linear relation between current and voltage if current is flowing through the diode. Now we have to understand what is a bilateral circuit. An electric circuit that possesses the same properties or characteristic in either direction is called bilateral circuit. A transmission line is the best example of the bilateral circuit because it can be made to perform its function equally well in either direction. So here you can see in the diagram there is a 5 kilo ohm resistance is connected across the 30 voltage source. So here you can see the polarity also. So what will be the current flowing through this circuit? That is 30 divided by 5. That means 6 milliampere current will flow through 5 kilo ohm resistance. Now if you are changing the polarity of the voltage source, that means now polarity will be minus to plus. So what will be the difference? Only the direction of the current will be changed. That means current will start flow from lower side to upper side, but the value of the current will be the same. So you can say this is a bilateral circuit. Just opposite of bilateral circuit is what? Unilateral circuit. An electric circuit whose properties or characteristics change with the direction of its operation is called unilateral circuit. A diode rectifier circuit is a unilateral circuit because it cannot perform similarly in both the direction. In this diagram, you can see there is a diode is connected between the AC supply and load, and this circuit is connected in series. So this diode will work only when it gets positive supplied across it. That means when its P terminal is connected to the positive and N terminal is connected to the negative, then it will work in forward bias direction. That means this diode will not work in the reverse bias condition. So this is an example of unilateral circuit. Now we have to understand what is a node. So in the diagram you can see the node. A node is a point in the network or circuit where two or more circuit elements are joined. For example, in this circuit diagram, A and B is the node point. Now we have to understand the another term that is called junction. A junction is a point in the network where three or more circuit elements are joined. It is a point where current is divided. In the above circuit, B and D are the junction. A junction must be a node, but node may or may not be a junction. Now we have to understand what is a branch of any circuit. The part of a network which lies between two junction points is called a branch. So in the diagram you can see DAB, BCD and BD are the branches of the circuit. Now we have to understand what is a loop. A closed path of a network is called a loop. So ABDA and BCDB are the loop in the given circuit. Now again we have to understand what is a loop. A loop is any closed path going through circuit element. To draw a loop, select any node as a starting point and draw a path through element and node until the path come back to the node where you started. There is only one rule. A loop can visit a node only one time. It is okay if loops overlap or contain other loop. Some of the loop in our circuit are shown here. So in the circuit you can see there are 6 loops. Now we have to understand what is a mesh. A mesh is a loop that has no other loop inside it. You can think of this as one mesh for each open window of a circuit, or the most elementary form of loop which cannot be further divided is called a mesh. So in this particular circuit there are 3 meshes. Now we have to understand what is a reference node. During circuit analysis, we usually pick one of the node in the circuit to be the reference node. Voltage at other nodes are measured relative to the reference node. Any node can be the reference, but two common choice that simplified circuit analysis are the negative terminal of the voltage or current source powering the circuit, or the node connected to the greatest number of the branches is usually called reference node. Now we have to understand what is a ground. The reference node is often referred to as ground. The concept of ground has 3 important meanings. First is, ground is the reference point from which voltage are measured. Second, the return path for electric current back to its source. Third, a direct physical connection to the earth, which is important for safety. Ground node gets its name from the third meaning, but the other 2 are equally important. You will come across the various symbols for the ground as shown in the figure. Now we have to understand what is a voltage source and what is a current source. The sources may be either a DC source or maybe the AC sources. So what is a DC sources? Any device that produces direct voltage output continuously is called DC source. Some of the commonly used DC sources are the batteries, DC generator and DC power supply, which is also called regulated power supply. It is also called UPS, that is uninterrupted power supply. Now we have to understand what is a AC source, or you can say alternating current source. Any device that produces alternating voltage output continuously is called an AC source. Some of the commonly used AC sources are alternator, an oscillator or signal generator. Now we have to understand what is the internal resistance of the source. The opposition to load current inside the DC source is called internal resistance. All DC sources like battery, DC generator or rectifier type supply have internal resistance and is represented by R suffix small I. The equivalent circuit of DC source is the generated EMF, that is E, is in series with the internal resistance Ri of the source as shown in the figure. So here you can see in the figure, that is battery and generator are shown here, and which have internal resistance Ri is connected in series with the voltage source or EMF source. And another circuit diagram you can see the DC source on load. There is a one battery source having voltage E, which is connected with internal resistance Ri across the load resistance RL. So supply voltage, or you can say terminal voltage V is equal to what? It can be written as V equal to E minus I into Ri, if this I is a current flowing through resistance Ri. If you want to calculate the voltage across load resistance RL, it can also be calculated as V equal to I into RL, where I is the current flowing through this circuit. So this load current can be calculated as I equal to E upon Ri plus RL, because these two resistance are connected in series. So equivalent resistance in this circuit is equal to Ri plus RL. Now as I already told you that if now you want to calculate the terminal voltage, this terminal voltage can be written as V equal to E minus IR, or it can be written as I into RL. So you have a value of I, that is I equal to E upon Ri plus RL. You just put this value in this equation. So you will get the equation of terminal voltage V equal to E upon Ri plus RL multiplied by RL. This can also be written as E upon 1 plus Ri plus RL. The voltage across the load terminal is reduced because of the voltage drop in the internal resistance of the sources. Our sources having smaller internal resistance will have a smaller voltage drop. Now we have to understand what is the ideal voltage source. A voltage source that has zero internal resistance is called an ideal voltage source. In such cases, the terminal voltage remains the same irrespective of the value of the load resistance. So as we know, the terminal voltage can be written as V equal to E upon 1 plus Ri upon RL. So in case of ideal voltage source, internal resistance is 0. So just put the value of resistance Ri equal to 0. So what will be the terminal voltage? Terminal voltage will be equal to V equal to E. That means terminal voltage is equal to the source voltage. Now we have to understand what is a practical voltage source. An ideal voltage source is not practically possible. If it would exist, it would supply an infinite current at short circuit, which is not possible. Therefore, all the voltage sources have some internal resistance that limits the current at short circuit condition. A practical voltage source is shown in the figure, which have voltage source E and having internal resistance Ri, which is connected in series. However, it is always preferred to have a source that has very small internal resistance, so that the terminal voltage of the source remains almost constant from no load to full load. A voltage source that has very low internal resistance as compared to the load resistance is known as constant voltage source. Now we have to understand what is the difference between voltage source and current source. In fact, a source can either be considered as a voltage source or as constant current source. When value of the load resistance is very large as compared to the internal resistance of the source is treated as a voltage source. However, when the value of the load resistance is very small as compared to the internal resistance of the source, then source is treated as the current source. Now how to convert voltage source into current source and current source into voltage source. So first is how to convert voltage source into current source. So first, find the internal resistance of any voltage source and keep this resistor in parallel with the current source. Then determine the current flow provided by the current source by applying the Ohm's law. In this figure, a voltage source with the resistance Rs is transferred into equivalent current source with a parallel resistance Rs. So Is is equal to what? Is can be written as Vs upon Rs. Now how to convert current source into voltage source? So first of all, find the parallel resistance of the constant current source and place in the series with the voltage source. Determine the open circuit voltage value of the voltage source by just applying the Ohm's law, and as per the Ohm's law you can write voltage equal to Is into Rs. Here you can see in the figure how the current source is converted into voltage source. Now we have to understand what is the ideal current source. A current source that supply a constant current no matter whatever is the load resistance is known as ideal current source. A symbolic representation of such an ideal current source is shown in the figure. The current supplied by the source should remain constant at all the values of the load resistance. Current source is a source that has high internal resistance. Now we have to understand the practical current source. An ideal current source is not practically possible. If it would exist, it would supply a constant current even at no load, which is not possible. A real current source is basically a voltage source that delivers almost the same current at all values of the load resistance. A source that has very high internal resistance as compared to the load resistance is considered as constant current source. A real current source having an internal resistance of 10 mega ohm with load resistance RL is shown in the figure. When load resistance varies from 1 kilo ohm to 100 kilo ohm, the current varies from 1.2 19988 microampere to 1.1881 microampere. This shows that load current remains almost constant and the source behaves as a constant current source irrespective of the value of load resistance. Now we have to understand what is Kirchhoff's current law. Kirchhoff's current law states that the algebraic sum of the current at any particular node or junction is equal to 0. So you can say at any particular node the algebraic sum of current is equal to 0, or you can say the sum of incoming current is equal to the sum of outgoing current. So here in the figure you can see that incoming current is equal to I1 and I2 and I6, and outgoing current is I3, I4 and I5. So you can write I1 plus I2 plus I6 is equal to I3 plus I4 plus I5. Now we have to understand Kirchhoff's voltage law. Kirchhoff's voltage law states that the algebraic sum of all the voltage around any closed loop in a circuit is equal to 0. In another words, the algebraic sum of all the potential difference around the loop must be equal to 0. So sigma V equal to 0. Here the term algebraic sum means to take into account the polarities and the sign of the sources and voltage drop around the loop. So in the particular diagram here you can see there is a two resistance, that is R1 and R2 is connected with the voltage source Vx. So here you can see the voltage source having a polarity -2 plus, and current I is flowing through resistance R1 and same current is also flowing through resistance R2. So there will be the voltage drop in resistance R1 and R2. So after applying the KVL you can write the equation Vs minus I into R1 minus I into R2 equal to 0. So you can write Vs is equal to IR1 plus IR2, or you can say Vs is equal to I into R1 plus R2. So when applying Kirchhoff's voltage law to a specific circuit element, it is important that we pay special attention to the algebraic sign like plus and minus of the voltage drop across the element and the EMFs of the source, otherwise our calculation may be wrong. But before we look more closely at Kirchhoff's voltage law, let us first understand the voltage drop across a single element such as a resistor. So here you can see there is a one resistive element, that is resistance, and current flowing through this resistance I. So what will be the voltage drop across this resistance? It can be written as V equal to minus I into R. Now you apply the KVL in this particular mesh. So as I already told you that it can be written as, because polarity of voltage source is -2 plus, so it can be written as positive Vs, that is Vs. Then there is a drop across the resistance R1, and again there is a drop across the resistance R2, that is IR2. So it can be written as Vs minus IR1 minus IR2 is equal to 0, or it can be written as Vs is equal to IR1 plus IR2, or it can also be written as Vs is equal to I multiplied by summation of R1 and R2. So in this particular session we have discussed different terminologies related to the DC circuit. We have understood what is the active circuit, what is a passive circuit, what is a unilateral circuit, what is a bilateral circuit, what is a linear element, what is non-linear element, and we have also discussed about what is the ideal voltage source, what is the ideal current source. At the same time we have also discussed how to convert voltage source into current source and current source into voltage source. And in the last we have discussed two basic laws, that is a Kirchhoff's voltage law and Kirchhoff's current law. So I am again repeating that Kirchhoff's current law states that algebraic sum of current at any particular node or junction is equal to 0. And as per the KVL, the algebraic sum of the voltage in any closed path is equal to 0. So this is all about the basic terminology related to the DC circuit. Thank you very much.